This is a video of the RCS AchiEV3rs, who are generously sponsored by Stubby's Precast. This was our main chassis at first, and this was our gripper. We tried to use a rack and pinion type gear, but that didn't work, so we made an arm. We got it programmed, and then we programmed it better so that it would go right in the middle. Finally, success. Before we got them all programmed, we had to use the motor control on the EV3, but eventually got it programmed. Except for one problem. The light blocks wouldn't work. Why was that? We dug deep into the programming to find out. We got it all sorted out though. Eventually we got our program completely made. It just needs a bit of fine-tuning yet. This is the RCS AchiEV3rs. Meet Matthew Van Beek, Ian Klein, Nathaniel Stam, Braden Overbeek, William Arnaudse, Johannes Schulten, and Colin Tenno. This is Josh Bile, our mentor. Right here, we are in Stubby's Precast, which is our sponsor and Josh Bile's workplace. We took a tour of it and saw all their giant robots.
I'm Ian Klein, and so on our robot we went through about 4 different ideas. So first we saw if we built a conveyor belt and then put an arm attached to it, then it could move back and forth and pick up the blocks and put them wherever. But then we abandoned that idea almost immediately because we figured out that the arm wouldn't really work. So it was actually a really bad idea. So their second idea was to build a chute, and so to do the weight sensor and whatever and put it into the chute, and then it would slide onto the spot it had to go. But then we also got rid of that idea because the risk was too great if the block would get stuck in the chute. So our third idea, we actually just was just a thought process. So we just kind of drew it on the idea. The main idea was to have a forklift and then to lift up the blocks, bring it to the right spot, whatever it had to do. But we also had abandoned that idea because we thought of a better idea. So the last idea, which was our final one, was to have a gripper system, and then we would put the block on the weight sensor, the gripper system would grab it, it would go to the right spot, and it would place it on the right spot.
My name is Nathaniel Stam, and so I'm just going to explain what our first problems were. So our first problem was just to get the weighing mechanism working out. So I got a picture here of our, I don't know if my teammate's going way back. So this is our first one, basically our first idea. And then we moved on along and got the idea that is on there right now. And so then that's basically it for our first idea. The problem is we just need the touch sensor. It's too hard. It takes too much weight to push it down to detect the heavy ones. So the heavy ones won't even push it down. So we first, right here, there's we put basically a lever, but then they'd go down even for the light ones. So we put elastic on there, as you can see, which made it not as much weight on the touch sensor. So then we just thought and played around with it basically, and we came up with that idea that's right on there. So then the challenge was to have a reliable moving mechanism. So we just thought of a tank-like track system, which is okay, but then the bottom would scrape the blocks. So then we just turned to wheels because it's a lot more simpler and a lot more reliable. Like, you don't have it very often that the wheels fall off, but then the tracks could come off a lot easier. So then we just called and figured out the body thing. So then let's throw the wheels on there, of course. And yeah, that's the finishing of the body and the moving mechanism type of thing. Get the block from the sensing contraption onto the challenge paper. So then our first idea was just to have it shoot. So this is our first idea, something like that. And then we thought, well, the block would probably get stuck, so we just scrapped that idea. And then we moved to like basically like a forklift, just to have the whole thing like all sensing and like 2-in-1 kind of thing arm. So then this is a rough picture of it, really rough. So, well, that we couldn't put all the sensors around that where the block would be, so we scrapped that idea too. And then we got to the idea of just having one contraption that senses it, and then another arm that grabs it from that contraption and puts it onto the challenge paper after the robot drove to the right spot. So that's what we have now.
My name is Jonathan Van Harden, and our first success is the weighing mechanism. This works like there's a lever here, and then it presses it down. The heavy ones will just push it down, and the light ones won't quite do it. Our second success is the grabber here. There's like a worm gear that turns, and then it will turn these two bigger gears, regular gears, and then the arms are attached to the shafts that are on these gears, and then that closes and opens the gripper. And yeah. So our third success is the Chase chassis, and yeah, we got wheels as you can see, and the motor is attached to the back wheels with two long shafts right there. You go from there all the way to there. And we attach the wires so they wouldn't knock the blocks out of place with elastics. That was this arm here, and it works great because it reaches all the way down to the ground where it can pick up the blocks and set them down, and all the way back to the weight and color sensor here.